Standard 2 is reason abstractly and quantitatively. Here we want students to be mathematically proficient and make sense of quantities and their relationships in problem situations. In order to do this, they need to bring two complementary abilities together and use them to problem solve. These abilities include the ability to decontextualize, to abstract a given situation and represent it symbolically in numbers and operational symbols, and then manipulate the symbols as if they have a life of their own. It also involves contextualization, which is the opposite skill, taking abstract mathematical symbols and creating a story problem to represent this in a real-world situation. Quantitative reasoning requires creating a coherent representation of the problem at hand. This also involves considering the units involved, attending to the meaning of the quantities, and not just learning how to compute them. Quantitative reasoning also involves knowing and being flexible in using different properties of operations and options. Each of these requires that we teach in a way that focuses on helping students figure out solutions, rather than teaching them the specific answers to problems. Standard 3 focuses on the student's ability to construct viable arguments and critique the reasoning of others. Students who are able to achieve this standard understand and use stated assumptions, definitions, and previously established results. They make judgments or guesses about the solution to a problem and are able to progress through a series of logical steps to determine how accurate or reasonable their guess is. Students are able to analyze situations by breaking them into cases and are able to resolve and use counterexamples. Students who can use constructive viable arguments and critique others are able to use details from a specific situation or problem and apply this information to general principles. They also take into account the source or the context of the data. For example, let's say that two students go to the store to buy a box of chocolates. The box of chocolates costs $8. If student A and student B both spend $4 each, then they could get the box of chocolates and they would share the box equally. However, if student A spent $6 and student B spent $2, the box of chocolates may not be shared the same way. These students are also able to compare the effectiveness of two plausible arguments, distinguish correct logic or reasoning, and if there is a flaw in the argument, explain why. Students working toward this standard at all grade levels can listen to or read the arguments of others, decide whether they make sense, and ask useful questions to clarify or improve their arguments. Let's look again at McCallum's model to help us make more sense of these standards. The figure shows us that standards 2 and 3 can be grouped together because they both reflect mathematical reasoning and explaining. Let's consider what standards 2 and 3 might look like in a lesson for students with significant cognitive disabilities. If we take this word problem, if Sam can mow one lawn in 2 hours, how many lawns can he mow in 8 hours? And we ask students to write a proportional relationship that represents this situation. Most students would write 1 lawn over 2 hours equals how many lawns as it relates to 8 hours. They would end up with an equation that displays 1/2 equal to x over 8. There are many ways that students can represent the relationship, but it can get overwhelming. It is easy to understand how many of our students could get overwhelmed. Consider how much easier it might be to engage in mathematical reasoning and explain the relationship if it were expressed in a more concrete form. There's nothing wrong with moving this back to a representational or more concrete form. If we represent this relationship using an image such as this, with each clock representing 1 hour, students can see a more concrete representation of the fact that 2 hours equals 1 lawn. Then we can expand the visual representation and ask our students, if I have 8 hours, how many lawns could I mow? Students can see that 2 lawns can be mowed in 4 hours and that 4 lawns can be mowed in 8 hours. This helps students not only prove their logic, but reason about their logic in a sophisticated mathematical way. Teachers need to have students discuss their thought process concerning their approach to answering any problem and debate whether they agree or disagree. Sometimes, encouraging reasoning or explanation with visual or object-based representations allows students to demonstrate a much deeper level of understanding than traditional mathematical notations allow. The next standard of mathematical practice is Standard 4. It requires students to model with mathematics. Students should be able to use the mathematics they know to solve the problems in everyday life, community, and the workplace. They should be able to identify important quantities in a particular situation and map those relationships using tools such as diagrams, two-way tables, graphs, flowcharts, and even formulas. Furthermore, they should be able to analyze those relationships mathematically to draw conclusions. Students who can model with mathematics should be able to routinely interpret mathematic results in the context of a situation and reflect on whether the results make sense or not. Standard 5 is related. It focuses on using the appropriate tools strategically. Mathematical tools are quite diverse. They include obvious tools like calculators and rulers, but also include manipulatives, graphs, diagrams, and other means of visually representing mathematical thinking. Students who are successful with Standard 5 are proficient at using the available tools when solving a mathematical problem. They are familiar with the tools appropriate for their grade or course and can make sound decisions about what each of the tools might help them accomplish. Using mathematical models, they know that technology can enable them to visualize the results of varying assumptions and explore consequences, compare, and predict using data. Mathematically proficient students at all grade levels are able to identify relevant external mathematic resources such as digital content located on a website. They are able to use any technology or tool that is appropriate for their level or grade to help them deepen their understanding, whether the tool they use is a ruler, a diagram, or any other mathematically appropriate tool. Looking once again at McCallum's grouping of the standards, we see that standards 4 and 5 group together into a category McCallum calls modeling and using tools. How might students with significant cognitive disabilities model mathematical understandings and use tools? Let's address the question with a specific example. What if you were posed with this problem? You're buying a new car, and it is on sale for $27,000. This is 80% of the original cost of the car. What is the original cost of the car? To solve this problem, students need to understand the concept of 100%. This can be done using a hundreds board. Hundreds boards are great mathematical tools that help us solve relatively difficult problems, yet they offer fairly concrete representations. In the case of this problem, the student must learn that the original cost is represented on the hundreds board as 100% of the board or all of the squares on the board. They can then use the board to determine that each column represents 10% of the cost of the car. If the sale price of $27,000 is 80% of the total cost, the student can fill in 80% of the squares on the board, or 8 columns. Given this information, the student can then divide $27,000 by 8 to determine what each tenth of the whole is worth, or what 10% of the car cost. Finally, the student can multiply that by 10, and it will give them 100% of the total car value. The hundreds board is a tool that makes it possible for students to reason through the problem and demonstrate understanding of the result.